Hello everybody and welcome again with tutorial number 3, clip 3. In this clip I'm going to show you how to spot a drill and drill the 4 holes in our part. This is our part, and what I want to do is to spot a drill these holes and then drill it. From toolpath I'm going to use drill. Then the message here is select one or more entities to add or remove from the features list. So we select the center point of the 4 holes, as we are going to spot a drill at these center points. Okay, notice that the selection of the center point of the hole should be logical, either clockwise, or maybe we can start here, we go counterclockwise. So click OK, and the drill is already selected. Then select the tool. To select the tool, I go to select library tool, and using the filter, the easiest way is to use the filter. Okay, then click none. And what I'm after is a spotted drill. Notice that when you hover over each tool, a tool tip will pop up to show the name of that tool. So we are looking for spotted drill, as you can see. So spotted drill, I'm looking for a spotted drill that has a diameter equal to 0.5, half inch. Okay, then we click OK. So the tool number 24 in this library, half inch spotted drill, is what we are after. Then, so we select this tool and then click OK. Tool number 1, this would be tool number 1 in our program. Length offset will be stored in H1. Tool diameter is half inch. Feed rate, maybe I will use 10 inches per minute. And for spindle speed, I'm going to use 2000 RPM. And I can add a comment here. It's very good to add comment always, so that machine operator can understand our program easily. So I'm going to say spotted drill, the 4 holes using spotted drill half inch diameter. Now notice that spindle speed is 2000 RPM and the spindle direction is clockwise. Now cut parameters to use the count cycle, the suitable count cycle. For this operation I'm going to use drill counter bore, which is G81. Nothing to change here. And we need linking parameters. I'm going to activate clearance 2 inches absolute, that is G90, and I use this clearance only at the start and end of operation. Retract position maybe 0.15 absolute. Top of stock, that is actually the Z0, so on top face is absolute. For depth, absolute. We can enter the depth here directly, 0.14, but I want to show you how to use the calculator. To use the calculator, okay, we override the depth and we enter the finished diameter to be 0.28125. Okay. Once you click OK, the depth value will be updated here. So we can calculate the exact depth value using the calculator by specifying a finished diameter. So what is finished diameter? If you look at this figure, this is the spotted drill, diameter half inch. Okay, so in order to specify or to calculate the required depth, okay, we need to specify the finished diameter, E. Finished diameter. H is the hole diameter. So if I want to make a chamfer if I want to make a countersink for this hole, nice chamfer for the edges, I have to specify the finish diameter. And normally finish diameter is less than the tool diameter and greater than the hole diameter. So our hole diameter is 0.25. That's why I chose finish diameter to be 0.28. This will determine how much chamfer will be here. Right? We are done here. That's all we need to do on this page. Coolant. Yes, I want to activate the coolant. So plug on. So coolant on, so that we activate M8. Okay, click OK. Okay. Now we can verify our operation. So if you verify, it's a good habit that you verify your operation before you proceed to the next operation. All right. On this simulator, this is a CNC simulator actually that is embedded in Mastercam. So I'm going to hide the axis. We can do a lot of things here. We can hide the axis. We can show the tool, the workpiece. We can also, for example, stop condition. I can stop the simulation when we have operation change. I can activate color loop so that we give different colors for different operations. Then we slow speed of the simulation by sliding this slider to the left. So we play. Okay, you can zoom in. So as you can see here, now when we drill, we're gonna have this nice chamfer of the upper edges of our hole.